So again, there are parts ang atong enzyme, and this is very general, no, for every enzyme. So, and we are looking into the models of how the enzyme would act, no, when it do its activity, catalyzing a particular reaction. So in the parts of an enzyme, there is actually what we call as an active site. An active site is a site in the general structure of the enzyme. There is a particular surface where it can actually detect or recognize a particular substrate. So wala gibutang diri, but it's a relatively small part of enzyme structure involved in catalysis. So may nga involved in a very specific term. This active enzyme is active enzyme. This active site rather, no, is the particular site of the enzyme that would actually recognize a particular substrate. For instance, this particular enzyme would catalyze the oxidoreductase reaction, katong kaganinang reaction, no, sa atong lactate. And this particular site of the enzyme is the one that recognizes the lactate molecule. So the lactate molecule, for instance, is our substrate. And if, for instance, this is the shape of the lactate molecule, no, and this is the one, this one is the site that would recognize that substrate. Kanang substrate is the compound or substance, no, or reactant, no, in which the enzyme will bind to. Okay, and in doing so, you will have what we call now as an enzyme substrate complex. It's an intermediate form when substrate binds to the active site. Again, this active site is very, very specific. Specific means siya to recognize a particular substrate. So particular compound, for example, this is the active site to this particular shape, no? It has a recognition ability actually that would recognize a particular substrate. So for instance, this is the shape of the lactate molecule. And this particular enzyme can only recognize that particular lactate molecule. If, for instance, we have another molecule, like for example, let's say another molecule, give me a molecule, let's say a glyceraldehyde, no? It's a glyceraldehyde, but let's say the itsura of the glyceraldehyde or the structure of the glyceraldehyde is like a square, no? So generally, pag tanaw mo structure of this enzyme, it could not recognize that other substance, no? Because it's not very specific, or there would be no possible interaction with this particular enzyme. But if na ay kaning a substrate, let's say with this particular shape, no, and our particular enzyme would be able to recognize this particular substrate, and in doing so, then they would have an enzyme substrate complex. So when there is an enzyme substrate complex, okay, then the enzyme can now catalyze para dali rama converts the substrate into the product. And then when the reaction occurs, after that, the product is now released from the enzyme. The models of action of enzyme is actually similar to the lock and key model, no? So tanaw na to ang lock and key model, diba? This is the lock, for example. Then na siya shape din sa ilalim siyang lock, and you have the key. The lock and key is actually similar to the enzyme and substrate model, no? Kani siya nga lock can only be opened by this particular key, no? Kani siya nga key, maka-insert lang niya siya diri nga lock kung mao ni siya nga key gid nga para ani nga lock, right? If you have so many keys at home, di gid niya siya ma-insert, di siya ma-open, and it's similar to the enzyme and the substrate. We can consider this one to be like our enzyme. The lock can be like an enzyme, and the substrate can be like our key, and they are very specifically made for each other. Then we can have the lock and key complex, and we can open, the key can open actually this particular lock here. You know, it's similar to the enzyme and the substrate complex. Once you have your enzyme that's very specific to a particular substrate, they can only bind so when the shape when the active site of the enzyme is very specific to a particular substrate. Otherwise, kung dili, then they will have no enzyme substrate interaction. But if the substrate fits specifically to the enzyme, then there you can have the enzyme substrate complex, and indeed your enzyme can then catalyze the reaction once you have this complex here. So pareha na siya sa lock and key model. If, for example, again, I have mentioned na kay square or rectangular nga shape, no? Or triangular nga shape, dili nyo na siya ma-fit in here very specifically sa imuhang enzyme, no? But probably another enzyme that would be that could possibly catalyze another kind of molecule. But for instance, this kind of molecule is very specific only to particular substrate. So we can also have the induced fit model on how the enzyme would act, no? What is that induced fit model? It's an active site changes shape to accommodate a substance. So for instance here, you have your active site here. Okay, you have the shape, and then you have the substrate with also this kind of shape, no? When the substrate enters the active site of the molecule, you actually form the enzyme substrate complex. And what happened? The enzyme changes shape slightly as the substrate binds. You notice here, naka-emerald triangle din here, and it's also an active site for your substrate, no, where it can bind, or this is your active site, it can bind with your substrate molecule. You notice that when this substrate and the active site would have a complex, no, murag ma-alter gamay ang shape sa imuhang enzyme. Okay, so for example here, murag medyo gamay lang ang iyahang curve. When it binds with your substrate, na form na gid siya, mura siya na form similar sa unsa ni nga for unsa nga shape, no, for your substrate. Like this one, ni fit gid siya, and it is being induced to fit into the similarly to the shape of your substrate. Kung triangular ni siya nga gamay, no, it will be fit into the shape of this kaning triangular molecule here. And this is what we call the induced fit model, na induce ang atong enzyme to fit this particular substrate, no. So again, the enzyme changes shapes. Dili pud dako, dili pud lisod pud nga square ni siya and triangle, no. Similar yung structure, but nalay slight changes, no, to the shape of your substrate. Okay, and you have this enzyme product complex, and then of course, as we have earlier shown, after the enzyme complex and the reaction inside the enzyme, no, then the enzyme can now release your products. Okay. By the way, any questions? There is what we call as enzyme specificity, no? So we are into the enzyme classifications and naming terminology used in enzymes. So for enzyme specificity, we learned that enzymes is very absolutely specific. Absolute specificity. There is absolute specificity for your enzyme. What does this mean? When you say absolute specificity, enzyme will catalyze a particular reaction for only one substrate only. One substrate. We say one substrate. One substrate. Like one compound. No? Very, very specific siya. I-catalyze na niya ang a particular reaction for only one substrate. Secondly, there is what we call as stereochemical specificity. When there is enzyme action, there is stereochemical specificity. In other words, enzymes can distinguish between stereoisomer. If you remember your organic chemistry, when we're talking about stereochemistry, di ba? Okay, later na wala na. You can actually remember na pag ma-change kani ang order lang within, for example, if there is an R sa imong organic group, sa imong substrate, and then si enzyme can simply recognize the S lang, dili ang R, no? So dili niya makatalyze ang reaction. This is what we call as stereochemical specificity because enzyme can distinguish stereoisomer. Maski pa og orientation in space lang ang nabali sa mga functional groups sa imuhang substrate, si enzyme can actually recognize that one. Third is there is what we call as group specificity. It involves structurally similar compounds that have the same functional group. So, pwede man niya ma-recognize kasi maingon ta din niya ang particular, it will catalyze in a particular reaction for only one substance, one substrate rather, and when there is a similar structure, similar functional groups to your substrate here nga itong giingon, actually it can also, it involves structural similar compounds that have the same functional groups. Pwede niya ma-catalyze gihapon, for example, as the same functional groups lang. No, man gitawag nga, sometimes mamimik, no, kay pag similar lang siya nga compound. And similar lang siya nga, rather functional groups ang iyahang makita. There's also what we call this linkage. The specificity involves the particular type of bond. So, for example, kung particular lang siya for amide, no, amide lang pwedeng niya i-catalyze. No? It involves only a particular type of bond. So, you call it one as linkage specificity. So, for the enzyme activity, the enzyme can actually be measured by its enzyme activity. Kung unsay kakayahan sa isa ka enzyme, no? We call that one as an enzyme activity. It's a measure of the rate at which the enzyme converts substance to products in a biochemical reaction. Kanang unsa siya ka kusog, no? Mo convert sa reactant to product. Manay itong gitawag og enzyme activity. So kung we're talking in a biochemical reaction, no, we're talking of unsa ang enzyme activity, no, unsa di ay kapaspason ang rate. Unsay is a measure rather, no, I don't know how to say it. It's a measure of the rate. Gibalik rin ako ang definition. It's a measure kung unsa lagi how fast, no, would the enzyme can actually convert a substance to another one. And there are actually factors that would affect the enzyme activity. Number one is temperature. So, na enzyme nga usually, no, na enzyme na pas siya makatalyze na particular temperature lang. For example, like 40 degrees or but lower than that, dili siya pwede. Okay, so ano man, posible nga ba the nature siya na remember that enzymes are made up of amino acids also, no? There is a component, there is amino acid. Majority of the component of the enzymes actually are proteins, no? It can be affected by the temperature. Possibly that when, for example, expose mo ang enzyme at a very, very high temperature, no? But nature ng enzyme, no? Ma-lose ng iyahang katong native structure niya. Okay. Also, you have the pH. There is a particular pH at which the enzymes can have its optimum activity. Remember, again, most of the enzymes are made up of amino acids. Okay, naman siya protein, no? Majority of its part is of protein. Remember, sa inyong protein discussion, no? There is what we call as isoelectric point of the protein. So, depende na kung unsang pH of the solution, no? Ma-alter po ang net charge of your enzyme sa solution. So, it will also affect sa iyahang binding ability. Okay, kung ma-change ang iyang iyang net charge, no, in a particular pH, no, ma-change ang interaction niya. So, ma-change ang iyang ionic interactions with the particular substrate. Then also, you have the substrate concentration sa isa ba niya? We also have the substrate concentration, okay? And then you have the enzyme concentration. Again, so there are 4 So again, the first one is the temperature. When the rate increases, usually for any enzyme, the rate increases as temperature increases. However, there is actually what we call as an optimum temperature. Okay, it's actually true for all enzymes. So let's say you have here the temperature versus the reaction rate. As you increase the temperature, no, of course, for any enzyme, increase din yung rate, but there is a certain maximum amount for that. As I mentioned earlier, it's possible na pagtaas na gitod kayo ang temperature, mo decrease na ang rate sa iyahang, ang rate sa reaction nga naman. As I mentioned, posible nga ma-denature na. There is denaturation due to the excess of heat. Again, your proteins are made up, your enzymes are made up of proteins at a very high temperature, ma-denature na siya. So there is only what we call an optimum temperature at which you can have an optimum enzyme activity. And nga nung ma-increase man, as you increase the temperature, nga nung ma-increase man at this kaninga point, paingon diri, no? When you increase the temperature, there is an increase also in the enzyme substrate collision. So, katong wala pa nag-bind yung mga enzyme, yung imong substrate, no? Pag you-increase the temperature, ma-increase po ang collision niya. So, ma-increase ang collision, maka-increase ang probability, chances that maka-form ng enzyme substrate complex. And kung magka-increase ang imong enzyme substrate complex, then magka-increase po ang conversion into the particular product. So temperature, the second one is the pH. And the same with temperature, there is also what we call as an optimum pH for which your enzyme can have an optimum enzyme activity. No, so the most enzyme exhibit maximum activity over a narrow pH range, usually just around 7 to 7.5. For biological system, in most biological system, enzymes usually operate in a narrow pH range between 7 to 7.5, except na lang, no, sa katong kuan nato sa atong tiyan, no, we have enzymes actually sa atong digestive system, no, and they act actually at a very low pH range. But for the rest of the enzymes in our body, in any biological system, the pH range at which the enzymes can actually act is around 7 to 7.5. And let's say in this case is where we have the optimum maximum or the maximum, the optimum pH rather, for which you can have the maximum rate or the optimum enzyme activity. And usually if you increase on the pH, also there is increase on the reaction rate, but again, mo reach the taog optimum. After that, you increase na po the pH, ma-denature na po ng atong enzyme, no? And so therefore, ma-decrease po ang rate of reaction. So again, alang tayo optimum pH for which your enzyme can have its maximum reaction. Next one is the substrate, no? Of course, expect nga kung magka-increase ang substrate concentration. For example, kung you want to convert proteins, you want the hydrolysis reaction of your proteins, amino acid linkage, or some amino acids, short amino acid polypeptides. If you have your polypeptides and you want to break all the peptide bonds to get your amino acids, no, it's increase on the concentration of, for example, your polypeptide, no, of course, magka-increase po ang rate of reaction. Again, the reason is increase on the substrate concentration, magka-increase ang collision, number of collision between your substrate and your enzyme. Kung daghan ang concentration, di ba? There is a greater probability that the collision between substrate and your enzyme would increase as you increase on the substrate concentration. So as you increase on your substrate concentration, because magka-increase ang iyahang collision, magka-increase po ng iyahang substrate complex formation, and because of that, magka-increase ang iyahang rate of reaction. So when you increase in the substrate, the maximum reaction rate for your enzyme actually also increases, and it actually, the rate approaches to a maximum. But there is what we call as the saturation curve, no? Napod na yung saturation curve po. So even if how how much increase you will have to your substrate, no, mo reach again na siya og maximum reaction rate. So enzyme activity increase up to a certain substrate concentration, thereafter remains constant. And this is what you call a saturation curve. Maski pag unsa siya taas na sa concentration, no ma-increase siya initially, pag taas na pud kayang substrate concentration, diha ra gid taman ang maximum reaction rate sa imuhang enzyme. And therefore mo agi gid siya og saturation. And there is what we call a term turnover number. It's a number of substrate molecules transformed per minute by one molecule of enzyme under optimum conditions of temperature, pH, and saturation. Natay turnover number. So maka-increase ang turnover number sa atong enzyme, is an indicator, no, as ang reaction rate, no, for your using your particular enzyme. So what limits enzymatic activity to a certain maximum value? A substrate, human ako balik-balik na ko. As the substrate concentration increase, the point is eventually reached where enzyme capabilities are used to their maximum extent, and the rate remains constant from this point on. Okay, so when each substrate must occupy, yan naman na siya. Nanang mo argument siya saturation. The rate remains the same. Nga naman, because each substrate must occupy an enzyme active site for a finite amount of time. Pag magamit na nimo ang enzyme, maski pagdaghan na kayo ka og substrate, no, there is a 1:1 interaction between your enzyme and your substrate, no. So maski pagdaghan kay ka og substrate pero sakto lang imong enzyme, no, mo agi ka og saturation because each substrate must occupy an enzyme active site for a finite amount of time, and the product must leave the site before the cycle can be repeated, no. And when each molecule is working at full capacity, the incoming substrate must wait their turn for an empty active site. So there you go. So turnover number, katatong giingin nga turnover, it's an indicator kung unsay kapaspas, no, ang for a particular enzyme to convert the substrate into its product. So for example, you want to convert carbon dioxide into carbonic acid using carbonic anhydride. You notice that you have the turnover number, you have 36 million, which means that you will have 36 million carbon dioxide that will be converted per minute to carbonic acid. And you have if you want to catalyze, for example, per hydrogen peroxide to water and oxygen, you also have this turnover number you have here. It's very large. And what else? So for example, the reaction between the addition of nucleotides to DNA haven't reached into nucleic acid yet, but this one is where you have your genetic information is contained with the DNA, no? And if you want to have a sequence of DNA molecules and use DNA polymerase, actually have 900 turnover number, no? It's 900 molecules of your DNA or nucleotides being added to your DNA chains. Okay, so again, this one is a measure of how fast, no, or the number of molecules for which you can there is your substance or your substrate being converted to your product. Number of substrate molecules, no, at an optimum pH. And the last one is your enzyme concentration. Okay, there are 4. Again, temperature, pH, you have the substrate concentration, the third, and the fourth is your enzyme concentration. This one, there is no saturation point, unlike the substrate concentration. Nga naman, si enzyme man ang magbuot, no? So kung taas kayo yung enzyme concentration, no, course, may increase imong reaction rate. Kay si enzyme man, kang enzyme ta magdepende, no? For that particular conversion of your substrate. So the greater the concentration of your enzyme, the greater be the reaction rate. If the amount of substrate present is kept constant, the enzyme concentration is increased, the reaction rate increases also. Maski pag constant lang imuhang reaction rate, pero gi-increasean nimo imong enzyme concentration. Okay. So for the enzyme, for the mechanism of the enzyme action, we have already mentioned this one. There's two models for which you can describe the mechanism of the enzyme action. The first one is the lock and key model. The active site has a fixed geometric shape like this one, as I mentioned earlier. And the second one is the induced fit model. The active site has a flexible shape and that can change to accept a variety of related substances, no? And pwede siya maka-accept more or less close here, but it will adapt, somehow conform, and be induced to accommodate your substrate. So you have that induced fit model and lock and key concept, which means nga dili gid siya inana bitaw ka mura plastic nga kung inana square nga shape, dili kay siya inana ka fit. Pwede nimo siya ma-induce, the enzyme can be induced, no, to fit the substrate. And of course, you have mentioned that there are 4 factors that affects the rate of enzyme activity. So question here, describe the effect that each of the following changes would have on the rate of reaction that involves the, so dapat i-quiz na niyo simple naman kayo ni. Describe the effect that each of the following changes would have on the rate of reaction that involves a substrate urea and the liver enzyme urease. Increasing the urea concentration, what will happen to the rate of reaction? So ang imong substrate is urea, ang imong enzyme is enzyme urease. Wala niya gistoryan sa iyang product. Anyway, simple naman niyo Increase, di ba? Of course, when you increase the urea concentration, that's your substrate. You expect nga, of course, may increase ang iyang rate of reaction, but only to a maximum, then you will reach a saturation. You increase anyone? Letter B, anyone? Increasing the urease concentration sa imong enzyme concentration, what will happen to the rate of the reaction?
Increase po, ma'am.
Is there a saturation? Is there a maximum? Letter B?
No, ma'am. No.
Wala. Okay, letter C, increasing the temperature from its optimum value to a value 10 degrees Celsius higher than this value. Anyone? Letter C? Nag-optimum value na kasi imong temperature. Optimum temperature na ka. Increasean pagid nimo, what will happen? So the rate of reaction, increase ba or mo-decrease?
Mag-decrease, ma'am.
Mag-decrease na. You already reached the optimum. Letter D, lowering the pH of the optimum value of 5 to a value of 3.
Decrease.
Kinsa ganito ni? Si Kuan na lang per me. Si, kinsa to? Si, kinsa to ni answer? Kinsa to ni answer? O, lain na pod, letter D. Anyone, letter D? Malangan na ta. Camela. Camela 1. Camela, are you with us? Arcelisa. Jane, Irish. Si Jasper ba to? Ikaw to Jasper? Jasper?
Yes, ma'am.
O, si Jasper na per me mag-istorya. So, lahi na pod be. Jinky. Grabe, shoutout sa akong gipang istorya, walay mo tingog. Ipa-quiz na lang siguro na ako ni, yung mga inani. Kate Abad, very familiar. Kate, wala. Sige, ako na lang itong dawaton ng giingon ni Jasper ha. O decrease, para di na tamalangan. Haday, ang atulog ang uban na niod to. Naniod to pa mo? Anyone? Tingog. Madunggan ko? Or si Jasper ay nakadungog sa ako? Madunggan ko?
Yes, ma'am.
Yes, ma'am.
Ang akong gipang tawag o Myra. Letter D, Myra. Ano sa may answer? What do you think, Myra? Kung decrease. Okay. Ito lang magod na ang question. Okay, basta mo reach ng optimum, no? So beyond and before the optimum, no? Mo-decrease gid ang iyahang value. Okay. So the mechanism of enzyme action, you have enzyme inhibition. The rates of enzyme catalyzed reactions can be decreased by a group of substances called inhibitors. So we know that enzymes increase the rate of reactions, but there's also what we call as inhibitors, no? Pwede niya i-decrease ang rates of reactions. Ang rates of reaction nga gihimo ni or induced by the enzyme. And we call that one as inhibitors. So enzyme inhibitors that slows or stops the normal catalytic function of an enzyme will do it by 3 modes, no? Unsaon man pag pahinay. So inhibitor, from the word inhibitor, inhibit niya, ihunong niya, stop niya, slow niya ang normal reaction using the enzyme. Unsaon man niya? It will have 3 modes. Number 1, it can do reversible inhibition, reversible competitive inhibition. Number 2, it can have reversible non-competitive inhibition. And number 3, it can do reversible inhibition. So, unsa man ang reversible competitive inhibition? So, for example, a molecule that sufficiently resembles an enzyme substrate in shape and charge distribution competes with the substrate for occupancy of the enzyme's active site. So, for example, lagi, you have your substrate here. This is your enzyme, no? This is your normal substrate. Pag naakay substrate or compound rather, if naakay another compound nga pari-pariha og shape ni substrate nimo, pari-pariha siya og charge distribution. For example, pari-pariha siya, one part is positive, another part is negative, no? Pari-pariha yung charge distribution, pwede siya mo compete sa particular enzyme. So kay gi-compete man niya, gigamit man niya si enzyme, no? To have this kind of complex substrate, mura siya o competitive substrate and enzyme complex, no? Gigamit mo niya sa enzyme mo na nga muhinay ang reaction. Rates of reactions because gigamit man niya some of the enzymes. It will compete with the normal substrate. And that is the reason why it can inhibit the enzyme action. Call this one as reversible competitive inhibition. So reversible kaya pwede man pud siya nga matanggal. Another one is reversible non-competitive inhibition. So a molecule decreases enzyme activity by binding to a site to an enzyme other than the active site. So, unsa man ang non-competitive? So, this is your enzyme when imong normal substrate. Ang non-competitive is na ay other site ang imong enzyme, no? Pero mohimo siya, mo bind siya sa imong enzyme. During a part, for example, during a part na mo interact siya, no? Mo bind siya. So, i-increase niya ang enzyme activity nga naman, maapektuhan siya, although wala siya ni bind sa active site, pero the overall activity of the enzyme will be affected, no? Kay ma-alter man ang imong enzyme once it binds to this site. Okay, call this one as non-competitive. Pag dili gani siya mo-compete sa active site, you call that one as a non-competitive inhibition. Another one is irreversible inhibition. A molecule inactivates enzyme by forming a strong covalent bond to an amino acid chain group of the enzyme's active site. And the enzyme, by doing this, the enzyme is permanently activated. So when you have an amino acid chain group and it forms a strong covalent bond, it will completely deactivate. So let's say here, now you have your enzyme. Iba you have this, more siya competitive inhibitor, but in the competitive inhibition manggod, weak ang intermolecular force of interaction here, which means pwede rin siya ma-release easily sa enzyme, right? Pero pag irreversible inhibition na, mo bind siya sa active site, and one of the amino groups here sa imong enzyme mo form of covalent bond interaction, see another substance, no, another substance, say another substrate, no, will form a covalent bond to a particular enzyme at a particular amino acid sa imong enzyme. Covalent, pag covalent bond formation na gani na siya, no, sa covalent bond, lisod din na siya tanggalon. So matawag din na siya nga irreversible. Pero the usual interaction between enzyme and substrate are ionic interactions. You can have hydrogen bond interactions, the usual interaction between enzyme and substrate to do the substrate enzyme complex. Uban, you can also use the van der Waals interactions or hydrophobic interactions, but never ng covalent bond interaction, because in the covalent bond interaction, mahimo na siyang irreversible. So when if there is another substance that will do covalent bond formation in one of the sites sa imong active site, then it will be called irreversible inhibition. Okay, so just remember there are just some other substance that could inhibit again the action of your enzyme. One again is reversible competitive inhibition. The other one is non-competitive inhibition. The third one is irreversible inhibition. Wala siya ginani, but there is a covalent bond formation. You have here. You have your substrate and you have your inhibitor. It forms a covalent bond here. So another substance will form a covalent bond. Okay, so question, identify the type of enzyme inhibition. Dali naman yun. Can already. Maybe I can ask this with a quiz. Stop again, sir. Identify the type of enzyme inhibition in each of the following inhibitor characteristics associated with an inhibitor that decreases enzyme activity by binding to a site on the enzyme other than the active site. What kind of inhibition is this? Letter A. 127. Huh? What kind? Reversible. Competitive, non-competitive. Competitive or non-competitive inhibition? Kung mo-bind siya to the site of the enzyme other than the active site, mahimo na siyang non-competitive. Mahimo lang siyang competitive kung katong active site na gid kani. Pag kani ang active site sa imong enzyme, diri pod mo bind ang imong
Competitive.
mahimo siyang competitive. Pero kung mo bind gani ang another substance other